It's Mr. Baker here with another physics video. Today we're going to be looking at the solar system. Today we're going to be looking at the solar system and we're going to be answering this question: what is the universe? So, a galaxy is a collection of stars, perhaps 2 billion stars. Our solar system lies on the arm of one of these galaxies called the Milky Way. Our solar system is a collection of 8 planets with, at the centre, the Sun. The Earth, our home, is the 3rd planet from the Sun. So, this is our solar system. What does this mnemonic help us to remember? So a mnemonic is something that you can associate in order to help you to remember some things. And yes, this one, you probably know my very easy method just speeds up naming. There used to be planets on the end of that. It's the order of the solar system, the order of the planets in the solar system. So we've got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Beyond our solar system, there are more planets than stars in the night sky. So far, we've discovered thousands of planetary systems orbiting other stars in the Milky Way, with more planets being found all the time. Most of the hundreds of billion stars in the galaxy are thought to have planets of their own, and the Milky Way is but one of perhaps 100 billion galaxies in the universe. Our solar system formed about 4.5 billion years ago from a dense cloud of interstellar dust and gas. The cloud collapsed, possibly due to the shockwave of a nearby exploding star called a supernova. When this dust cloud collapsed, it formed a solar nebula, a spinning, swirling disk of material. At the centre, gravity pulled more and more material in. Eventually, the pressure in the core was so great that the hydrogen atoms began to combine and form helium, releasing a tremendous amount of energy. With that, the Sun was born. And eventually, it amassed more than 99% of the available matter. Matter further out in the disk was also clumping together. These clumps smashed into one another, forming larger and larger objects. Some of them grew big enough for their gravity to shape them into spheres, becoming planets, dwarf planets, and large moons. In other cases, planets did not form. The order and arrangement of the planets and other bodies in our solar system is due to the way the solar system formed. Nearest the Sun, only rocky material could withstand the heat when the solar system was young. For this reason, the first 4 planets, Mercury, Venus, Earth, and Mars, are terrestrial planets. They're small, with solid, rocky surfaces. Meanwhile, materials we're used to seeing as ice, liquid or gas, settled in the outer regions of a young solar system. Gravity pulled these materials together, and that's where we find the gas giants Jupiter and Saturn, and ice giants Uranus and Neptune. As well as the Sun and the planets, there are other objects in our solar system. The solar system has 5 dwarf planets. You can see here the most well known, Pluto. It is smaller than our moon. The others are Ceres, Haumea, Makemake and Eris. A dwarf planet orbits the Sun but is not large enough to clear its orbit of space debris like a normal planet. The asteroid belt is another group of objects in our solar system. It is a collection of asteroids that orbit the Sun between Mars and Jupiter. An asteroid is a rocky, airless remnant left over from the creation of the solar system, sometimes called minor planets. Not all are in the asteroid belt. Comets also orbit the Sun. Comets are cosmic snowballs of frozen gases, rock and dust, roughly the size of a small town. When a comet's orbit brings it close to the Sun, it heats up and spews dust and gases into a giant glowing head, larger than most planets. Meteoroids are objects in space that range in size from dust grains to small asteroids. Think of them as space rocks. When a meteoroid enters Earth's atmosphere, or that of another planet, like Mars, at high speed and burns up, the fireballs, or shooting stars, are called meteors. Similar to the asteroid belt, the Kuiper belt is a region of leftovers from the solar system's early history. The Kuiper belt is thought to be one of the sources of comets in our solar system. The Oort cloud is the most distant region of the solar system. It starts 1,000 times further out from the Sun than we are. Even the nearest objects in the Oort cloud are thought to be many times farther from the Sun than the outer reaches of the Kuiper belt. Unlike the orbits of the planets in the Kuiper belt, which lie mostly in the same flat disk around the Sun, the Oort cloud is believed to be a giant spherical shell surrounding the rest of the solar system. It's like a big, thick-walled bubble made of icy pieces of space debris the sizes of mountains, and sometimes larger. The Oort cloud might contain billions or even trillions of objects. A star is formed from a nebula, a giant cloud of dust and gas. Gravity acts between the particles of the nebula and pulls them in towards each other. As the cloud collapses, pressure squashes the hydrogen gas so much that fusion occurs. The hot, dense core of the cloud becomes a star. Not all this material ends up as part of the star. The remaining dust can become planets, asteroids, or comets, or may remain as dust. A star gives off light because it's so hot. Part of the EM radiation it emits is in the visible spectrum. 99% of the star's radiation is ultraviolet, visible light, or infrared. Main sequence stars like our Sun are in the main stage of their life. Stars are fusing elements together. In stars the size of the Sun, hydrogen is fusing into helium. Their size remains constant for millions of years. Fusion inside the star maintains their energy output. The pressure produced by the outward radiation from fusion balances with the gravitational forces pulling inwards. So that's the end of this one. These are the things you should be able to do. You should be able to describe our place in the universe and the variety of objects within the solar system. You should be able to describe the formation of a protostar and planets and how evidence from the early solar system is gathered. And you should be able to explain why a star radiates light. So that's been our lesson on the solar system, and we started off the lesson by asking this question: what is in the universe? Well, in the universe there are galaxies, and in the galaxies there are billions of stars. Around those stars are planets, and around our Sun is our solar system. The Earth, which is the third planet from the Sun, has got a moon also around it, and there are all those other things we talked about like comets, meteors, and asteroids. Okay, so that's been our lesson on the solar system. I've been Mr. Baker, and this has been another physics video, and I'll see you next time. Thanks very much.